Today we are going to discuss about center of mass. What is center of mass? It is a point where the entire mass of the body is assumed to be concentrated. It is the point where the entire mass of the body is assumed to be concentrated. For example, if this is a circular ring, the point where the geometric center is called the center of mass. If you take a square plate, it is nothing but the intersection of diagonals. So center of mass is a point where the entire mass of the body is concentrated. We can calculate the center of mass by using a formula. We can calculate the center of mass by using the formula HCM is m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. This is the equation to calculate the center of mass. For example, if the body is lying in a plane, or few bodies are lying in a plane, we have even XCM as well as YCM. So we can write the X coordinate and Y coordinate. Let us discuss few numericals. In our material, page number 304, the question number 1. See 10 gram, 30 gram and 60 gram are located at a points 20 centimeter, 40 centimeter and 80 centimeter on a live meter scale. So this is a live meter scale, that means 100 centimeter length. Here at a distance of 20 centimeter, one mass is there. At a distance of 40 centimeter, one mass is there. And even at a distance of 80 centimeter also we have the mass. We should calculate where is the center of mass. It's a direct substitution question. We can just write HCM as M1 in this case is 10 and even both are in CGS, so I'm just putting it in the same unit system. 10 into 20 plus 30 into 40 plus 60 into 80 divided by the total mass 10 plus 30 plus 60. So it is 200 plus 1200 plus 4800 divided by 100. It is nothing but 48 plus this one. It is 6000. 6200 divided by 100. That is nothing but 62 centimeter. This is the answer. Next question. Question number 3. Question number 3. There are 3 masses it's located, 2m, m and 3m. And they gave this height as h and this as a and even this distance as b. For this type of question, in this question all the bodies are arranged linearly. It means only in one axis. But here you see this 2m and m are situated along the x-axis. But if you consider this one, it has both x coordinate and y coordinate. For this type of question, the first method we should write the coordinates. If you write the coordinate here, I can write this as a comma 0. If you write the coordinate here, I can write a plus b comma 0. If you write the coordinate here, it is a plus b comma h. So I have written the coordinates here. So for this question, I have XCM as well as YCM. XCM means take the x coordinate here, that is 2m into x coordinate here it is a plus here m into a plus b plus here 3m into a plus b divided by the total mass 2m plus m plus 3m. So if you multiply it, it is 4ma plus ma plus nb plus 3ma plus 3mb by the total mass is 6m. You can write this as 5 plus 3. It is 8ma plus 4mb by 6m. If you cancel, I can write 4 by 3a plus 2 by 3b. This is about our XCM. Same like that, for this question, we have the YCM also. We should even calculate, it's in page number 304 only. Even I can calculate YCM, that is 2m into 0 plus m into 0 plus 3m into h by the total mass is 6m. That is 3mh by 6m. That is nothing but h by 2. And even in few answers, they will give like coordinate XCM, YCM as XCM, YCM. They will write like this coordinate, that is 4 by 3a plus 2 by 3b, h by 2. Even in few answers, they will give like vector form 2 by 3a, 4 by 3a plus 2 by 3b of I plus h by 2j. So just now I discussed a question in which the body which is arranged linearly, and this is the case in which we arranged in a plane. Next question. Assume that there are 6 identical masses are placed at the corners of a regular hexagon. 6 identical masses are placed at the corners of regular hexagon. For example, M, 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 N and M. And all the sides length are L. Where is the center of mass located? If it's a regular hexagon and all the masses are same, obviously the center of mass is located at the center. But in this question, I'm telling this same thing, but we are just doubling one mass. So one corner mass I'm just doubling. So what happened for the shift in the center of mass? What is the shift in center of mass in this question? Same like the previous question, we can do the coordinate analysis first. We should write the coordinates. I'm just taking the case in which this is center and this regular hexagon is placed in an XY coordinate system like that I'm taking. So if we take it like that, 2m is situated at a distance of L from here. But this is at a distance of L by 2. So I'm going to write the coordinates here. So this part, I can even write it as this 2m is located at a distance of L, 0. But m is located at a distance of L by 2 and even the y-axis is root 3 L by 2. Cos 60 and sin 60. Here also, this will come in the negative x-axis and positive y. So minus L by 2 and root 3 by 2 of L. This is in the negative x-axis only. So minus L comma 0. This, both the coordinates are negative. So minus L by 2 root 3 by 2 of L. So we are writing here the cos 30 and sin 30, or even terms of 60 also we can do it, because we know that the angle between these two sides are 120 degree. If you do it like that, it's a 60 degree. Then the x-axis will be cos 60 and the y-axis will be sin 60 will come. So I'm going to calculate the shift in center of mass. For that, I'm just writing HCM. You just start from here. I'm writing this is 2m into L plus, if you take here the y-axis, because this mass, obviously you remember, all the masses are same, and even the 2m is placed along x-axis. So your center of mass will shift here only, shift towards the x-axis. So y coordinate, if you are solving also, it will get cancelled. YCM will get 0. HCM, I am calculating 2m into L plus m into L by 2 plus m into minus L by 2 plus m into minus L plus m into minus L by 2 plus one more term, m into L. This coordinate I did not write. This is L by 2 comma minus root 3 by 2 of L. This is the first one, second one, third one, fourth one, fifth one, and even the sixth is L by 2 divided by the total mass 2m plus the rest all masses are m plus m plus m plus m plus m plus m. How many m's should be there? Totally 6, one more mass, so it's 7m should come. This L by 2 minus L by 2 cancel. Then this L by 2 minus L by 2 cancel. So I can write 2 ml minus ml by 7m. That is ml by 7m. So answer is nothing but L by 7. What is the shift? Shift also it will be L by 7 and it is going to L by 7 minus 0 because the first it was at the origin. So its shift in the center of mass is L by 7. I'm not writing YCM because I have taken it like this. YCM, if you calculate YCM, all the terms will get cancelled. See, here it's 0, here L by 2, root 3 L by 2. Here it will come as this, both the values will be plus, this both the values will be minus. So this will be cancelled with this will be cancelled with this, even this x-axis both are coming as 0. So YCM total will come as 0. So it has only x coordinate. Or even you can remember in this way also, the high mass or the mass which is more is equated along the x-axis only. So center of mass also shift towards x-axis. This question is not there in our material. It is like you can just write one of the corners of a regular hexagon is with mass 2m. Is with mass 2m. The same question they can ask in another form. Instead of one point, make it adjacent 2 points if you take the mass. This also we can do it in a shortcut form. So what is the question? The same question only. Here I am just marking. The same question, instead of one mass, the two masses. You can do with the coordinate system also, no problem. This is 2m, even this also is 2m. Rest all the masses are m only. Rest all the masses are m. What happened for the center of mass? So in this case, you can do a shortcut form. You can take that these two are the two masses. So obviously the center you just calculate with this, because the rest all are identical masses and they are even numbers get cancelled. So you see this is 2m, this also is 2m. So this is the center. The distance from this point to this point, it is nothing but root 3 by 2 of L. The distance from the center point to this is nothing but root 3 L by 2. So you can even calculate the shift in center of mass by the shift in CM. We can even calculate by another formula. What is the masses here? Here also 2m, here also 2m. And the distance it is root 3 by 2. So here both the masses we are adding. So I can just write it is 2m into root 3 by 2 of L by the total mass is 8m. 2 will get cancelled. So the answer is root 3 by 8 of L. This is the shift in which the adjacent two places we are doubling the masses. Adjacent two places we are doubling the masses. So total we are taking here these two questions. Initial case we are taking the regular hexagon and all the corners we are placed with the same masses. M, 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 M. All are of equal mass, and in those cases center of mass is situated at the center. And this is the case in which the first case what I marked is one mass we are doubling. So I have taken this mass for double. So we calculated HCM. In the second case, they are taking the two masses are doubling. Two masses are doubling. So this I have taken another approach, like where is the center located? These two they have taken. And this I am just taking here, this center is located at the midpoint of this. And from that midpoint to the original center, where was the center of mass located before? That is 2m into xcm, because the first, when we are taking the shift, always we take with respect to the center. So 2m into root 3 by 2 of L by the total mass. Root 3 by 8 into L. These are the two separate cases of a regular hexagon. Even these all the questions we can do it in the same form, like if you don't want this method, even you can follow the same method. In which write the center of mass. Take it this also 2m and calculate the same method. This is like a shortcut method here. Now textbook, there is a question in page number 322. Page number 322, question number 10. Instead of a hexagon, they gave 4 identical particles, each of mass arranged at the corners of a square. If the mass of the particle at the end of one side is double, and one at the end of a side are double. So in this case, what is happening? First case, all the corners are situated with the mass m. Second case, they are taking one is double. So instead of m, m and this m, this I will take this 2m. Here also we can do the same method. Or like the shortcut form what we told, we can take here, that is only one mass. So you take here this mass. The distance from this mass to the center, original center. What is this distance? The diagonal is root 2L. Root 2L by 2 is nothing but L by root 2. So here in this case I can calculate the shift by 2m into L by root 2 divided by, what is the total mass they are? Total mass is 5. Total mass is 5. And see here, what is the additional mass only we should take? Additional mass is total already M are there. So that is the identical system. Other than that, the added mass is only M. We should write here the added mass, M into L by root 2 by 5M. So it is equal to M and L can cancel. So 5 root 2. Just see in the previous question I have written here 2m because in two places we are adding the masses. So that's what in the previous cases I have written here it is 2m into the distance from that point to the center I have taken. Just revise in the previous one. Previous one I just placed it two places. Here and here. 2m here. Here also 2m is there. So I'm just taking this point because both the places 2m. So this m and this m together I am writing 2m in the equation. But in this case only in one place we are adding. So it is m. So n into L by root 2 by 5 by L by, that is equal to L by 5 root 2. Page number 322 it is. Page number 322. You can do two questions as homework. Question number 9, question number 8 and question number 11 you just try. Same page number 322 and like a homework you can just do it. Page number 322, question number 8 and 11. So what we learn in this section? In this section, we just calculated the center of mass of few cases. We have taken the first when the body is arranged linearly. Next, we have taken with the coordinate system. After that, I have taken two regular hexagon case. One is all are regular. Second case, I have taken one mass is double. And then I have taken the 2 points, the masses are getting double. Then the next case is with square we are doing. You just try with these two examples. Next section I will come with some other questions of center of mass. Thank you.